right, let's look at ionic compounds. Specifically, we're going to be naming with polyatomic ions. All of our previous ionic compounds have had monatomic ions, meaning there was just one atom. So, for example, iodine, which had a -1 charge, is a single atom ion. Calcium, which has a +2 charge, is also a single atom ion. So these are both monatomic ions. We are now going to be using the polyatomic ion. So that's things like CO3 2-. Okay, so this is the ion right here. These are the atoms in the ion. So 1 carbon and 3 oxygen atoms, but it has a -2 charge. We could also look at NH4, 1 or +1, the 1 is understood. So this has 1 nitrogen atom and 4 hydrogen atoms, and when all 5 of those atoms are together, it's a +1 charge. Now, these are polyatomic. So poly means many or multiple, so notice that there are multiple atoms in each of these ions, and they act as a single ion. Okay, now you don't have to memorize a bunch of different polyatomic ions. They are in your reference pages. Okay. And one of the easiest things about polyatomic ions is that when you have a polyatomic ion in an ionic compound, you don't have to change the name or change the ending of the name. So, for example, this is ammonium. So if you had, for example, ammonium chloride, the ammonium stays the same. That doesn't change. The chlorine changes, just like it did before, and it has the ending "ide." CO3 2- is carbonate. So it has a -2 charge. What if I had calcium carbonate? That's CaCO3, calcium carbonate. And notice we just say the words calcium carbonate. It doesn't change. It doesn't change to "ide" or anything like that. This is the ionic compound. Here is a monatomic ion, and here's a polyatomic ion. Remember, calcium has a +2 charge, carbonate has a -2 charge, so they cancel each other out. That's why we can just have calcium carbonate for this particular example. Okay, let's look at some additional ones. Now, this is also similar to the previous ones where we were talking about naming, because if you are given the compound, it's very simple to name the compound. So if I just gave you NH4 NO3, your task here, the hardest part really, is going to be identifying that that is a polyatomic ion and this is a polyatomic ion. So this is ammonium nitrate. So again, looking at the formula and coming up with the name is not as difficult. Okay, we could have CaOH2. Okay, now we'll look at that in a second, but at going in reverse. But if I just gave you this, you should be able to tell me that that is calcium. That's a monatomic ion, so calcium. And this OH is a polyatomic ion. It's hydroxide. So this is calcium hydroxide. That would actually be the name for it. Now, how would we go from this name? I'm going to cover up the formula. How would we go from calcium hydroxide to the chemical formula? Well, it's actually the same thing that we were doing with the previous, like the regular monatomic ions. Calcium has a +2 charge, and hydroxide is OH with a -1 charge. Now, again, you don't have to memorize these polyatomic ions. They are in your reference pages, but you can just go back and do the crisscross method. So this 2 and this 1 are going to crisscross each other. And now you have just the 1 calcium, and you have 2 hydroxides. Now, the thing to remember here is that this polyatomic ion, it needs to be in parentheses so that when you say there's two of them, you are referring to the entire ion rather than just the hydrogen. So make sure that if you have multiples of a specific polyatomic ion, then it is in parentheses. All right, let's try another one. Let's look at magnesium phosphate. Okay, so we need to say, all right, well, magnesium I know is Mg, and it has a +2 charge. And then phosphate, based on the polyatomic ion chart, is PO4 3-. Now, PO4 is the, that 4 does not have anything to do with the charge. Only the 3 here has to do with the charge. This means that there's 1 phosphorus and 4 oxygens in this ion. Okay. Now, we're looking at these charges here, and the magnesium has a +2, and the phosphate has a -3. So if we did the crisscross, that means that we would need 3 magnesiums, and we need multiples of our phosphate. Based on here, we need 2 phosphates. So if I gave you magnesium phosphate, you would need to be able to give me this compound, or that chemical formula. Okay. The best way to remember this is to continue practicing it. That's really, truly the only way to do it. Let's look at another one. Let me find some space over here. Let's say I've got sodium sulfate. Okay, now sodium has a +1 charge, and sulfate is SO4 2-, has a -2 charge. Again, you are just doing the crisscross. So you're going to need 2 sodiums, and you're only going to need 1 sulfate, so it doesn't even need to be in parentheses. You can just write SO4. So you need to be able to go from sodium sulfate to this chemical formula. All right. Try some of the practice problems that are on the worksheet, and in the next video I'm going to do naming with transition metals, which can get a little bit more challenging. But again, the best way to get the hang of this is to continue practicing.